Hello everyone, and welcome to my channel. Here, we explore the fascinating world of science, from the mysteries of the universe to the wonders of everyday life. Sit back, relax, and let us discover something amazing together. Tonight, you find yourself standing at the quiet edge of something vast. Something almost too large to hold in your thoughts all at once. Above you, stretching endlessly in every direction, is the universe, a deep, silent ocean of darkness scattered with distant lights. Each of those faint points is a star, and around many of those stars, often hidden from direct view, are worlds. Planets. Thousands of them have already been discovered, and scientists now believe there are billions more quietly circling in the dark, each one following its own path, each one shaped by forces both familiar and strange. For a long time, you might have imagined planets as places somewhat like Earth's solid ground, a blue sky, perhaps oceans, maybe even life. It's a comforting idea, a familiar template. But as you begin to look closer, gently, patiently, that idea starts to dissolve. Because the truth is far more unusual. Some planets orbit so close to their stars that a single year lasts only a few hours. Others drift so far away that their surfaces never feel warmth, only an endless, frozen stillness. There are worlds where the sky may glow with vaporized metal, and others where clouds are not made of water, but of glass or even stranger materials you've never encountered. You might begin to notice that Earth, for all its beauty, is not the standard. It is simply one example, and perhaps a rather rare one. As scientists have refined their tools, quietly measuring the faint dimming of starlight, or detecting the subtle wobble of a distant sun, they have uncovered a universe that feels less like a neat system, and more like a vast, unfolding collection of experiments. Some planets are swollen and light, like soft spheres of gas stretched to their limits. Others are dense and heavy, packed tightly as if pressed by invisible hands. Some spin gently, while others are locked forever, showing only one face to their star, one side in constant daylight, the other in endless night. And there are even planets that have no star at all. They wander alone through the darkness, carrying with them whatever warmth remains deep inside, like quiet embers drifting through space. As you continue to explore, you begin to understand something subtle but important. The universe does not repeat itself. Instead, it varies endlessly. Each world is shaped by its own history, its own position, its own delicate balance of forces. Some are born from swirling disks of dust and gas, slowly gathering material over time. Others may form through violent collisions, fragments merging into something new. And still others may not even belong where they are, having been pulled from distant systems and captured long ago. In this way, planets are not just objects. They are processes, stories in motion. And as you listen, you might start to imagine what it would feel like to stand on one of these distant surfaces, if such a thing were even possible. Perhaps you would feel the ground shifting beneath your feet, softened by heat. Or perhaps there would be no ground at all, only thick atmosphere stretching downward into darkness. The air, if it could be called that, might shimmer with unfamiliar chemistry, carrying scents and textures beyond human experience. Time itself might feel different. On some worlds, a single day could last longer than an entire year. On others, the cycle of light and darkness might be so rapid that it blurs into something almost continuous, a flickering rhythm instead of a steady passage. It's a quiet reminder that even the things you take for granted, day, night, seasons, are not universal truths. They are local habits. As you drift further into this thought, you begin to see the purpose of this journey more clearly. Tonight is not about memorizing facts or collecting information. It is something softer than that. You are here to explore gently the diversity of planets beyond our solar system, to understand, in a calm and unhurried way, how scientists have learned to detect these distant worlds without ever touching them. And perhaps most importantly, to recognize just how wide the possibilities truly are. Because once you accept that planets can be this varied, this unpredictable, it becomes easier to imagine that life, too, might not be limited to the patterns you already know. That possibility doesn't need to be loud or dramatic. It can simply rest there, quietly, like a distant star present, but not demanding your attention. And as you continue, moving slowly from one idea to the next, you may find that the universe feels less overwhelming, and more like something you can gently drift through. A place of soft mysteries, rather than harsh unknowns. In the next part of this journey, you'll begin to explore some of the most extreme worlds ever discovered, planets where heat, pressure, and motion stretch far beyond anything experienced on Earth. Worlds that, in their own quiet way, remind you just how flexible reality can be, and just how far it can go. As you drift a little deeper into this quiet exploration, you begin to notice that not all planets are gentle places. Some are intense, not in a loud or chaotic way, but in a steady, overwhelming sense, as if the environment itself has been turned far beyond the settings you're used to. Heat, pressure, light, and motion all push to their limits, until the idea of weather begins to feel unfamiliar. You might start with a world that orbits very close to its star, closer than anything in your own solar system. Here, the light is not soft or distant. It is constant, heavy, almost physical in its presence. The surface, if there is a solid surface at all, glows faintly, as if warmed from within. Temperatures rise so high that metals, the same ones you might imagine as solid and cool, begin to melt and even evaporate. Iron can drift upward like mist. Stone can soften into slow-moving rivers. On some of these worlds, scientists believe there may be entire landscapes made of molten rock, oceans of lava stretching across the surface, gently shifting over time. Not violent, not explosive. Just slow, glowing movement, like thick liquid under a dim red sky. And above it, the atmosphere may carry particles of vaporized minerals, forming clouds unlike anything you've seen. Clouds that do not bring rain. At least, not the kind you know. Because on certain planets, rain still exists, but it falls in a very different form. Imagine standing beneath a sky where tiny shards of glass drift together in the upper atmosphere. Carried by winds moving faster than sound, these particles eventually fall. Not softly, but sideways, driven by powerful currents that never seem to rest. It is a strange thought, but a real one, a reminder that even something as familiar as rain can take on entirely new meanings when the conditions change. And then, there are planets that seem to be disappearing. Slowly, quietly. Almost like breath fading in cold air. These worlds orbit so close to their stars that their atmospheres cannot hold together. The intense radiation stretches and pulls at the outer layers, allowing gases to escape into space. Over time, a long, thin tail may form behind the planet, similar to the tail of a comet. If you were watching from far away, you might not even notice the change at first. But year after year, the planet grows lighter, thinner, less complete than it once was. It is not a sudden ending. It is a gradual unmaking, and yet, even in this, there is something calm. A steady process, unfolding over immense stretches of time. Not all extreme planets are defined by heat. Some are defined by absence. There are worlds so dark that they reflect almost no light at all. Their atmospheres absorb incoming radiation, trapping it instead of scattering it. To an outside observer, these planets appear almost invisible, faint shadows against the brightness of their stars. If you could stand there, which you cannot, but you can imagine, the sky might not brighten in the way you expect. Light would arrive, but it would not bounce back. It would sink, quietly, into the layers around you. A kind of darkness that is not empty but full. Then, there are winds. You might be used to the feeling of air moving gently across your skin, or perhaps stronger gusts during a storm. But on some distant planets, winds can reach speeds of several kilometers per second, fast enough to circle the entire planet in just a few hours. These winds are not chaotic in the way storms on Earth can be. They are constant. Driven by the sharp contrast between a permanently lit side and a permanently dark side, the atmosphere is always trying to balance itself. Heat flows, air moves, and the planet breathes in a slow, endless cycle. You begin to realize that many of these extreme conditions are not random. They follow patterns. Planets that are tidally locked, always showing the same face to their star, develop two distinct halves, one side in eternal day, the other in endless night. Between them, there may be a narrow band where temperatures are more moderate, a thin region sometimes imagined as a place of balance. A twilight zone. Not quite bright, not quite dark, just in between. And perhaps, just stable enough for something interesting to happen. As you continue to drift through these ideas, you may notice something quietly fascinating. Even the most extreme worlds are not chaotic. They are consistent. Each one follows its own set of rules, shaped by gravity, distance, composition, and time. What feels strange to you is simply normal for that environment. A planet of lava is not unstable there. It is complete. A world of glass rain is not broken. It is functioning exactly as it should. And in that realization, something soft begins to settle in your thoughts. The universe does not aim for comfort. It aims for possibility. In the next part of this journey, you will move beyond extremes and begin to explore planets that are not just harsh, but truly unusual in their composition, worlds made of unexpected materials, with structures that challenge even the basic definition of what a planet can be. Some light, some heavy, some almost impossible. As you move gently onward, leaving behind the intensity of extreme environments, you begin to notice something even more unusual. Not just how planets behave, but what they are made of. Because here, the strangeness is not only in temperature or wind or light. It is in the very substance of the world itself. You might begin with a planet where carbon, the same element that forms the basis of life on Earth, exists in a very different arrangement. Under immense pressure, deep beneath the surface, carbon atoms can compress into crystalline structures. Over time, layer upon layer, this process may create vast regions of material similar to diamond. Not small gems, not scattered fragments, but entire interiors shaped by this structure. From a distance, this idea feels almost decorative, like something imagined rather than observed. But it is grounded in real chemistry, shaped by conditions far beyond anything found on Earth. These so-called carbon-rich planets remind you that even familiar elements can behave in unfamiliar ways when placed under different pressures and temperatures. And then, you may encounter something lighter. Planets so diffuse, so expanded, that their density is lower than what you might expect. These are sometimes called puffy planets, gas giants that have been heated and stretched by their nearby stars. Their outer layers swell outward, becoming extended and soft, almost like a loosely held cloud. If you could somehow move through one slowly, carefully, you might not feel a clear boundary between atmosphere and interior. Instead, there would be a gradual thickening, a deepening pressure, as if you were descending into something that never quite becomes solid. They are large, but not heavy in the way you might expect. A quiet contradiction. And on the other side of that contrast, there are planets that are the opposite, incredibly dense, compact worlds where matter is packed tightly together. Some may be the remnants of larger planets that have lost their outer layers, leaving behind a core rich in metals. Iron, nickel, compressed into a smaller volume, creating a surface gravity far stronger than what you are used to. Standing there, if it were possible, would feel different. Each step heavier, each movement slightly more deliberate. Not dramatic, but noticeable, like carrying an invisible weight that never leaves you. Between these extremes, you begin to see that planets are not defined by a single template. They exist along a spectrum. And within that spectrum, there are categories that appear again and again. You might hear about super-Earths, planets larger than Earth, but still rocky in nature. Some may have thick atmospheres, others may be more exposed. Their surfaces, if they have them, could vary widely. Some smooth and quiet, others shaped by tectonic movement or volcanic activity. Then there are mini-Neptunes, smaller than the gas giants you know, but still wrapped in thick layers of gas. These worlds may not have a solid surface at all, at least not one you could reach. Instead, they fade from gas into fluid, and perhaps into something denser below, without a clear dividing line. They are not quite Earth-like, and not quite like Neptune. They are something in between. And this in-between category turns out to be one of the most common types of planet discovered so far, a gentle reminder that the most typical worlds in the universe may not resemble anything in your own solar system. As you continue, you begin to notice something else, something less visible, but just as important. Some planets are hidden. Not because they are far away, but because their atmospheres obscure everything beneath. Thick layers of haze or vapor can cover the entire planet, scattering light in such a way that it becomes difficult to see what lies below. In some cases, this haze may be made of complex hydrocarbons, forming a kind of permanent smog. In others, it may be composed of steam water heated until it no longer behaves like a liquid or a gas in the way you expect. A world of vapor. A place where the idea of surface becomes uncertain. And then, there is ice. But not the kind you know. In the cold outer regions of planetary systems, or deep within certain interiors, Water can freeze under such high pressure that it forms structures unlike ordinary ice. These forms, sometimes called Ice 7 or Ice 10, are dense, crystalline, almost rock-like. They do not melt easily. They do not behave gently. They exist under conditions where pressure shapes matter more than temperature. So even something as simple as water, something so familiar, so essential, becomes something else entirely. As you take this in, slowly, you may begin to feel a quiet shift in perspective. The word planet no longer points to a clear image. It becomes broader, softer, less defined. A planet is no longer just a place like Earth. It is any world that has gathered itself together under gravity, regardless of what it becomes afterward. And that realization opens the door to something even more curious. Because if planets can be made of diamond-like interiors, or stretched gas, or compressed metal, then where, exactly, do you draw the line between a planet and something else? There are objects in space that sit very close to that boundary, too large to be simple planets, but not quite massive enough to ignite as stars. These are sometimes called brown dwarfs, and they exist in a quiet middle ground. Not shining like stars. Not passive like planets. Something in between. Once again, the universe resists clear categories. It prefers gradients, transitions, subtle shifts instead of sharp edges. And as you rest in that thought, you begin to see a pattern forming not just in the planets themselves, but in the way the universe builds things. Nothing is fixed. Everything is shaped, reshaped, adjusted over time. In the next part of this journey, you'll begin to explore how these worlds move, the paths they follow, the rhythms they keep, and the strange, sometimes musical patterns that emerge as planets orbit their stars in ways both familiar and deeply unusual. As you continue your slow journey, you begin to notice that planets are not only defined by what they are made of, or the conditions they endure, but also by how they move. Movement, in the universe, is rarely random. It follows patterns, some simple, some intricate, shaped by gravity, time, and the quiet pull of nearby objects. And when you begin to observe these patterns closely, they reveal something almost rhythmic. You might start with a familiar idea, a planet orbiting a single star, tracing a path that repeats again and again. A steady cycle, a predictable return. But beyond that familiar image, there are systems that behave quite differently. There are planets that do not orbit just one star but two. These are called circumbinary planets, and their motion is a little more complex, a little more delicate. Instead of circling a single point, they move around a pair of stars that themselves orbit each other. The sky on such a world, if it could be seen clearly, might hold two suns rising and setting in shifting patterns, sometimes close together, sometimes far apart. Light would not arrive in a steady rhythm. It would vary, gently, over time. And yet, even here, the motion is stable, predictable, balanced. Gravity, though invisible, keeps everything in place. As you drift further, you may encounter planets with orbits that feel unusually fast. These worlds circle their stars in just a few hours, completing what would be an entire year in less time than it takes for a single day to pass on Earth. Time, on such a planet, would feel compressed. Seasons, if they exist at all, would blur together, repeating again and again in rapid cycles. There would be no long waiting, no gradual change. Just a continuous, flowing repetition. And then, in contrast, there are planets whose orbits are so wide, so stretched, that a single journey around their star may take hundreds or even thousands of Earth years. On these worlds, time expands. A single season could last longer than a human lifetime. The sky might change so slowly that it feels almost still, a quiet, patient shift that unfolds across generations. Fast and slow, compressed and extended. Once again, the universe offers variation instead of uniformity. Some planets move in ways that are not just fast or slow, but tilted. Their axes lean at unusual angles, causing extreme seasonal changes. Others may rotate in the opposite direction of their orbit, a motion known as retrograde rotation. From the surface, this could make the sun appear to rise in the west and set in the east, reversing the pattern you are used to. It is not wrong. It is simply different. And then, there are systems where planets seem to move in quiet coordination with one another. These are called resonant systems. In such arrangements, the orbital periods of planets are linked by simple ratios 2 to 1, 3 to 2, or other gentle relationships. When one planet completes 2 orbits, another completes exactly 1. Their motions stay in sync, repeating over long periods without drifting apart. If you imagine this carefully, it begins to feel almost like music. Not a sound you can hear, but a pattern you can sense. Each planet moving along its path, keeping time with the others, forming a kind of gravitational harmony. A slow, silent rhythm playing out across the darkness. And yet, not all systems are so stable. Some are more chaotic. Planets may have highly elliptical orbits, moving close to their star at one moment, then drifting far away at another. Their paths stretch and compress, creating cycles of heat and cold that are far more extreme than anything on Earth. In some systems, gravitational interactions between planets can lead to gradual changes or even sudden shifts. A planet might be nudged into a new orbit, or, in rare cases, ejected entirely, sent drifting into space without a star to orbit. A quiet departure. No explosion. No sudden flash. Just a slow change in motion, until the connection is lost. And this brings you to another subtle idea. Not all planets stay where they are formed. In the early stages of a planetary system, when dust and gas are still swirling around a young star, planets can migrate. They may form far away, in cooler regions, then gradually move inward, drawn by interactions with the surrounding material or with other planets. This process, known as planetary migration, helps explain why some large gas giants are found extremely close to their stars, places where they could not have formed originally. They have traveled, shifted position over time, and now rest in places that seem, at first glance, unexpected. As you take this in, you begin to see that orbits are not just paths. They are histories. Each curve, each tilt, each resonance tells a story of how a system evolved, of how planets interacted, influenced one another, and settled or sometimes failed to settle into stable arrangements. And through all of this, there is a quiet consistency. Gravity does not rush. It does not act suddenly, without cause. It shapes motion slowly, steadily, over immense spans of time. Like a craftsman working patiently, adjusting one detail at a time. There is no need for urgency. Everything unfolds at its own pace. As you rest in this understanding, the movement of planets begins to feel less abstract, and more like something you can gently follow. A pattern, a rhythm, a quiet dance. In the next part of this journey, you will begin to explore places where these movements, combined with just the right conditions, might allow something even more delicate to exist, environments where the possibility of life, in one form or another, begins to emerge. As you move forward, carried gently along these patterns of motion and matter, you begin to arrive at a softer question. Not how planets move, not what they are made of, but whether, somewhere among them, something might be alive. It is a quiet thought. Not urgent. Not demanding. Just a possibility. For a long time, you may have imagined life as something closely tied to Earth, to water, to air, to a narrow range of temperatures. And it is true that, so far, Earth is the only place where life is known to exist. But as you've already begun to notice, the universe does not limit itself to familiar conditions. So perhaps life does not either. You might begin with the idea of a habitable zone, a region around a star where temperatures allow liquid water to exist on a planet's surface. Not too hot, not too cold. A gentle balance. It sounds simple, almost reassuring. But even this idea begins to shift as you look closer. Because a planet does not need to sit perfectly within this zone to be interesting. There are worlds that may exist just at the edge of it, places where the conditions are not evenly balanced, but divided. On a tidally locked planet, for example, one side faces the star at all times, while the other remains in darkness. The day side may be too hot, the night side too cold, but in between, there may be a narrow band where temperatures are more stable. A place of soft light, a region where the star never fully rises, but never fully disappears either. This is sometimes imagined as a twilight zone, a ring around the planet where conditions might be calm enough for something delicate to persist. Not everywhere, just in that thin, in-between space. And then, there are ocean worlds. Planets covered almost entirely by deep, global oceans, water stretching far below the surface, possibly with no continents at all. The pressure in these depths could be immense, shaping the water into layers that behave in unfamiliar ways. At the bottom, under enough weight, water may even transition into those dense, crystalline forms you encountered earlier, ice that behaves more like rock. Between the surface and that hidden boundary, there may be vast regions of liquid water, gently circulating over time. If you imagine drifting there would be no land beneath your feet. Only depth, stillness, and slow movement. Some scientists consider these worlds to be promising places in the search for life, not because they resemble Earth exactly, but because they offer stability and time. And time, in the universe, is often the most important ingredient. But water is not the only source of warmth or energy. There are planets and moons where heat does not come primarily from a star, but from within. Through a process called tidal heating, gravitational forces from nearby objects can stretch and compress a planet repeatedly, generating internal heat. This warmth may keep subsurface oceans in a liquid state, even if the surface above is frozen solid. So even far from the light of a star, a world might still hold warmth, hidden beneath layers of ice or rock. It is a quiet kind of warmth, protected, persistent. And then, there are ideas that stretch even further. What if life does not require water at all? What if it does not rely on carbon, the element that forms the basis of all known life on Earth? These questions remain open. Some scientists explore the possibility of alternative chemistry systems built on different elements, functioning in environments that would seem hostile to anything familiar. Methane, ammonia, or other compounds could, in theory, support processes that resemble life, even if they look nothing like it. It is not something you can easily picture. And perhaps that is the point. Life, if it exists elsewhere, may not announce itself in ways you recognize. It may be subtle, unfamiliar, quietly unfolding in forms that do not match your expectations. As you rest in that thought, you may begin to feel a shift not in what you know, but in how you imagine. Instead of asking, "Is this planet like Earth?" you begin to ask, "What is possible here?" And that question opens far more doors. Because possibility does not require certainty, it only requires space. And the universe, as you have already seen, has plenty of that. You might also begin to notice that life, wherever it exists, does not need to be complex or advanced to be meaningful. Even the simplest forms, microscopic, slow-moving, barely noticeable, would represent something profound. A quiet persistence. A way for matter to organize itself, to adapt, to continue. Not dramatic, just present. And so, the search for life becomes less about finding something extraordinary, and more about recognizing something subtle. A faint signal, a small imbalance in an atmosphere, a chemical trace that does not quite fit. These are the clues scientists look for, not direct evidence, but gentle hints that something might be happening. And even when those hints remain uncertain, they are enough to keep the search going. Because the question itself is worth asking. As you drift gently through these possibilities, you may find that the idea of life in the universe no longer feels distant or unlikely. It feels open, unresolved. A quiet space where something could exist, even if you do not yet know what it looks like. In the next part of this journey, you will step into even stranger territory, planets that do not orbit stars at all, worlds that exist in isolation, or in systems shaped by unusual events. Places that remind you that not every world belongs where you expect it to be. As you continue drifting gently through these distant systems, you begin to notice that not every planet fits neatly into a pattern. Some do not orbit a star at all. Some belong to systems that have already changed beyond recognition. And some seem to carry the quiet memory of something that happened long ago. You might begin with the most solitary of them all. Rogue planets. These are worlds that travel through space without a parent star, moving slowly through the darkness like quiet wanderers. They were not always alone. Most of them likely formed within planetary systems, circling a star just as Earth does. But at some point, something shifted. A close gravitational encounter. A subtle imbalance. And over time, the planet was gently pushed outward, its orbit stretching further and further until it could no longer return. There is no dramatic moment when this happens. No sudden break, just a gradual release, like something slipping from your hand without you quite noticing when. And once it is free, the planet continues onward, not aimlessly, but steadily, following the quiet pull of gravity across the galaxy. You might imagine what it would feel like to stand on such a world. There would be no sunrise, no shifting light, only a deep, constant night, interrupted perhaps by distant stars faint and unmoving from one moment to the next. The sky would not change in the way you expect. Time would pass, but without the familiar markers that help you feel it. And yet, even here, there may be warmth. Deep beneath the surface, the planet may still hold heat from its formation, slowly released over time. If there is water below, it could remain liquid, hidden beneath layers of ice, a quiet ocean sealed away from the cold of space. Not visible, not obvious, but present. From there, you move to a different kind of world, one that still orbits a star, but a star that is no longer what it once was. Stars do not last forever. Over immense stretches of time, they change, they expand, shed their outer layers, and eventually collapse into dense remnants, white dwarfs, neutron stars, or other compact objects. What remains is quieter, dimmer, and far more stable in a different way. And yet, planets can still exist around them. You might imagine orbiting a white dwarf, the small, cooling core of a once bright star. The light here would be soft, faint, almost like an echo. The warmth reduced, but not entirely gone. It is a different kind of environment. Less intense, more still, but also shaped by a past that was anything but calm. Because for a planet to remain in such a system, it must have endured the transformation of its star, the expansion, the loss, the shifting gravitational balance. Or perhaps it formed afterward, from the material left behind. Either way, it carries a history that is not immediately visible. A quiet resilience. And then, there are planets whose origins are marked by something more sudden. Collision. In crowded systems, where multiple large bodies move through shared space, interactions can sometimes lead to impact. Not small, surface-level events, but massive collisions enough to break apart entire worlds. Fragments scatter, debris spreads outward, and over time, gravity begins its patient work again. Pieces come together, slowly, gently, almost without urgency. Something new begins to form. A planet built not from untouched material, but from remnants. Its composition mixed, its structure altered, its past written into every layer. If you could look closely enough, you might find traces of what came before, hints of multiple origins combined into a single world. It is not broken. It is rebuilt. And as you continue, you begin to step back slightly, seeing not just individual planets, but entire systems. Some are crowded. Dozens of planets orbiting a single star, each at a different distance, each moving at its own pace. Their paths may be carefully spaced, balanced in such a way that they rarely interfere with one another. A quiet arrangement, stable over long periods. If you imagine observing such a system from afar, it might feel like watching a slow, layered motion, each planet tracing its own circle, all of them connected by gravity, yet distinct. A kind of order. Not perfect, but consistent. And then, in contrast, there are systems that contain only one known planet. A single world orbiting its star, without companions. No neighboring planets. No complex interactions, just one orbit, repeating again and again. It is not incomplete. It is simply solitary. And there is something quietly striking about that. Because it reminds you that there is no single way for a planetary system to exist. Some are busy, filled with motion and interaction. Others are quiet, minimal, almost empty by comparison. Neither is more correct than the other. They are just different outcomes of the same underlying processes. And as you let this settle, you begin to notice a pattern that goes beyond any individual example. Each system is shaped by its own history. The number of planets it contains, their sizes, their distances, their interactions, all of these are the result of countless small influences over time. Collisions, migrations, captures, losses, each event leaving its mark. No two systems are exactly the same. Not in structure, not in behavior, not in outcome. And so, instead of seeing planets as isolated objects, you begin to see them as parts of larger stories. Stories that unfold slowly, without intention, guided only by the steady rules of physics. Some stories are complex, filled with movement and change. Others are simple, almost still. But each one is complete in its own way. And in that realization, something soft becomes clear. The universe does not follow a single script. It writes many, quietly, patiently, across the vastness of space. In the next part of this journey, you will begin to explore how, from a small world far away, humans have learned to notice these distant planets not by traveling to them, but by reading the faint signals they leave behind. As you move gently onward, leaving behind these distant and varied worlds, you begin to notice something quietly remarkable. All of the planets you've imagined, the molten landscapes, the drifting wanderers, the layered atmospheres. None of them have ever been touched. Not one. And yet, somehow, from a small world orbiting an ordinary star, humans have learned to detect them, to sense their presence across distances so vast that even light takes years to travel between them. It is not done through direct sight. Instead, it is done through patience, through careful observation, and through learning how to read very small changes. You might begin with one of the simplest and most widely used methods, the transit method. Imagine watching a distant star, steady and bright, its light reaching you after a long journey through space. At first, nothing seems to change. The brightness remains constant, a quiet, reliable signal. But then, very slowly, almost imperceptibly, the light dims. Not by much. Just a fraction, as if something has passed in front of the star, blocking a small portion of its light before moving on. This is what scientists look for. A planet crossing, or transiting, the face of its star from your point of view. Each time it passes, it creates a tiny dip in brightness. And if this dimming repeats at regular intervals, it begins to form a pattern, a signature that suggests a planet is there. You are not seeing the planet directly. You are noticing its shadow. A soft interruption in the light. And from this small change, scientists can begin to learn more. The size of the dip can hint at the size of the planet. The timing of each transit reveals how long it takes to orbit its star, a quiet rhythm, recorded in light. If you imagine this process, it feels almost like watching a distant candle flicker, except the flicker is not random. It is precise, repeating, meaningful, a signal hidden in stillness. But not all planets pass directly in front of their stars from our point of view. Many remain invisible to this method. So scientists have learned to look for something even subtler. The gentle motion of the star itself. Every planet, no matter how small, exerts a gravitational pull on its star. And while the star is much larger, it does not remain perfectly still. Instead, it responds, moving slightly, shifting back and forth in a small, slow motion. This is known as the radial velocity method. If you could observe the star closely enough, you would notice that its light changes ever so slightly as it moves toward and away from you. Not in brightness this time, but in color, shifting between slightly bluer and slightly redder tones. The change is extremely small, far too subtle for the human eye. But with precise instruments, it can be measured. And from that measurement, scientists can infer the presence of a planet, estimating its mass, its orbit, its influence on the star. Once again, the planet itself remains unseen, but its effect is felt, like noticing the movement of water, and understanding that something beneath the surface must be causing it. As you continue, you begin to encounter something even more delicate: the study of planetary atmospheres. When a planet passes in front of its star, a small portion of the starlight filters through the outer layers of its atmosphere before reaching us, and as that light passes through, certain wavelengths are absorbed, depending on the gases present. This process is called spectroscopy. If you imagine light as a kind of message, a stream carrying information, then an atmosphere acts like a filter, subtly altering that message. By analyzing these changes, scientists can begin to identify the chemical composition of the atmosphere. Traces of water vapor, hints of methane, signals of carbon dioxide, not seen directly, but detected through their influence on light. It is a careful, patient process. The signals are faint, often buried in noise, requiring repeated observation and precise interpretation. And even then, there is uncertainty. The data must be compared with models, tested against different possibilities. Nothing is assumed too quickly, because in such distant observations, clarity comes slowly. And yet, Despite these challenges, something remarkable has happened. From these methods, transit, radial velocity, spectroscopy, thousands of planets have been identified. Their sizes estimated, their orbits mapped, their atmospheres, in some cases, partially understood, all without leaving Earth or its immediate surroundings. You begin to realize that this is not just a story about planets. It is also a story about perception, about how humans have learned to extend their senses not by reaching farther physically, but by becoming more attentive to subtle patterns. A slight dimming of light, a faint shift in color, a barely detectable signal. Each one, on its own, might seem insignificant, but together, they form a picture, a quiet reconstruction of something distant and unseen. And there is something deeply calm about this approach. It does not rush, it does not demand certainty. It allows for uncertainty, for revision, for gradual understanding. It listens, carefully, patiently. As you rest in this idea, you may begin to feel a quiet appreciation for the process itself. Not just the discoveries, but the way they are made through observation, interpretation, and time. And perhaps, in a way, it reflects the journey you've been on here. Not rushing from one idea to the next, but moving slowly, allowing each thought to settle before continuing. In the final part of this journey, you will step back once more, looking at the broader meaning of all these discoveries, what they suggest about the universe, about our place within it, and about the quiet mystery that still remains. As you reach this final stretch of the journey, you begin to slow down a little. Not because there is less to explore, but because there is more to take in. You have moved through worlds of heat and shadow, through strange compositions and quiet motions, through possibilities of life and the methods used to detect what cannot be directly seen. And now, gently, you begin to step back, to look not at one planet or one system but at the larger picture, the galaxy itself. Within the vast spiral of the Milky Way, there are hundreds of billions of stars, and around many of these stars, as you now understand, there are planets, not just a few, but countless. Worlds forming, drifting, changing. Some familiar in small ways. Most entirely different. You may begin to sense the scale of it, though it never fully settles into something easy to grasp. Numbers this large tend to soften at the edges of thought, becoming more like impressions than exact figures. But even as an impression, it is enough. There are not just a few unusual planets. There are billions. And each discovery, each small dip in starlight, each subtle shift in motion adds something new to that picture. Not always something dramatic. Often just a detail, a refinement. But over time, those details accumulate. And slowly, quietly, your understanding changes. At one point, it may have seemed reasonable to think of Earth as a kind of standard, a reference point for what a planet should be. Solid ground, breathable air, moderate temperature. A comfortable model. But as more planets are discovered, that model begins to loosen. Not disappear. Just expand. Earth becomes one example among many. Not central. Not typical. Just one outcome, shaped by a particular set of conditions. And this realization does not diminish its value. If anything, it adds to it. Because it shows how specific, how finely balanced, those conditions are. At the same time, it opens the door to something else. The idea that there are many ways for a planet to exist. Many paths a system can take. Many outcomes that are stable, even if they feel unfamiliar. And within this, you begin to notice a quiet balance. The universe is not chaotic in the way you might expect. It follows rules. Gravity shapes motion. Physics governs structure. Chemistry defines interaction. These rules are consistent, applying equally across vast distances. And yet, the results are incredibly varied. From the same basic principles, you get lava worlds and ice giants, puffy planets and dense cores, quiet systems and dynamic ones. Order, leading to diversity. Structure, allowing for variation. It is a gentle paradox. The universe is both predictable and surprising at the same time. You can understand the rules, and still be surprised by the outcomes. As you sit with this idea, something begins to settle. Perhaps the goal is not to fully understand everything, not to reduce the universe to a simple explanation, but to become comfortable with its openness, to recognize that there will always be more to learn, more to discover, more to notice, and that this is not a limitation. It is part of the experience. You might also begin to see that each discovery, no matter how small, shifts the way you think not just about distant planets, but about your own place among them. Earth is not isolated. It is part of a much larger context, a single world within a vast collection. And while that may sound overwhelming at first, it can also feel grounding, because it places you within something expansive, but not chaotic. Something structured, but not rigid. A system that allows for both order and possibility. And within that system, human understanding continues to grow. Slowly, carefully, without rushing. Each new observation builds on the last, forming a deeper, more detailed picture over time. And even when that picture remains incomplete, it is still meaningful, because it reflects the process of learning itself. Not immediate, not perfect, but steady. And so, you arrive at a quiet conclusion. Not a final answer, but a gentle understanding. The universe is vast, and filled with worlds more varied than you might have imagined. Human knowledge, though limited, is expanding, reaching outward, piece by piece. And the journey of discovery is still at its beginning. There is no clear endpoint waiting ahead, no moment where everything will suddenly become known. Only a continued unfolding. A slow, patient exploration. And perhaps, that is enough. Because in that openness, there is space not just for answers, but for curiosity, for wonder, for the quiet act of noticing. And as you rest here, at the edge of what is known, you may find that the universe feels a little less distant, and a little more like something you can gently exist within, not needing to understand all of it, just enough to appreciate its depth. As everything begins to settle, you find yourself returning not to a single place, but to a feeling, a sense of quiet distance, gently filled with light. You have moved, slowly and carefully, through a universe that is far more varied than it first appears. You have imagined worlds shaped by heat, by pressure, by motion, by time. You have drifted past planets that glow, planets that freeze, planets that wander alone, and others that move in quiet harmony. And now, as you pause, it becomes easier to gather these impressions together. Not as a list, not as something to memorize, but as something to feel. The first thing that remains is a simple truth. Planets are not all the same. They do not follow a single pattern, or conform to a single idea. Some are dense and heavy, others light and expanded. Some are calm, others shaped by extremes. Some are familiar in small ways, while many exist in conditions that feel entirely outside your experience. And yet, each one is complete in its own way. Not unfinished, not incorrect, just different. As you rest with that idea, you begin to notice how much of what you once assumed about what a planet should be, what conditions are normal, what environments are possible has quietly shifted. Earth, for all its detail and complexity, is no longer the center of comparison. It becomes one example among many. A very specific outcome, shaped by a particular balance of distance, composition, and time. And that does not make it less meaningful. If anything, it adds depth. Because it reminds you that the conditions you experience every day, the air you breathe, the water you drink, the steady rhythm of day and night, are not universal features. They are local, precise, and perhaps, in their own quiet way, rare. At the same time, this shift opens something else. If planets can exist in so many different forms, then the idea of life, too, begins to expand. It no longer feels limited to one set of conditions, one type of chemistry, one familiar pattern. Instead, it becomes something more open, something that might adapt, persist, or emerge in ways that are not immediately recognizable. This does not mean that life exists everywhere. It simply means that the possibilities are broader than once imagined. And that is enough to keep the question alive. Gently, without urgency. As you continue to reflect, you may also notice how these discoveries have come about. Not through sudden leaps, but through careful observation. Small changes in light, Subtle shifts in motion. Faint signals, repeated over time. From these quiet clues, entire worlds have been inferred: their sizes, their orbits, even hints of their atmospheres. It is a reminder that knowledge does not always arrive all at once. Sometimes, it builds slowly, piece by piece. And in that slow accumulation, something meaningful takes shape. You may begin to feel a quiet respect for that process, for the patience it requires, for the willingness to accept uncertainty, to revise understanding, to remain open to new possibilities. Because even now, with thousands of planets discovered, what you know is still incomplete. There are limits to what can be observed, biases in what is easier to detect, questions that remain unanswered. And yet, these limitations do not stop the process. They simply shape it, guiding where attention goes next, where new tools are developed, where curiosity continues to reach outward. And so, you arrive at something that feels less like an ending and more like a pause. A place where what has been learned meets what is still unknown. The universe remains vast, not just in size, but in possibility. There are still worlds that have not been detected, systems that have not been understood, conditions that have not yet been imagined. And that is not something to resolve. It is something to sit with, quietly, because within that openness, there is room for discovery, for reflection, for the simple act of wondering. You do not need to reach every corner of the universe to appreciate it. You only need to recognize that it is there, expanding, unfolding, continuing, whether you are watching or not. And perhaps, as you let this final thought settle, you begin to feel a sense of calm in it. Not everything needs to be known. Not everything needs to be explained. Some things can remain as they are: distant, quiet, and full of possibility. A soft presence at the edge of awareness. Something you can return to whenever you need space to think or space to rest. And so, we've reached the end of tonight's wandering. Whether your eyes are still open or already drifting, thank you for keeping me company here among distant stars, quiet worlds, and the soft patterns that hold them all together. If this brought you a little calm, a little space to rest, you're always welcome to return, or to share it with someone who might need a slower, softer moment. For now, rest well. You're safe, you're warm, and the universe can keep watch.